essence of traditional education is centered on teaching, not learning. This education methodology usually entails teachers transmitting information to students via teacher lectures, worksheets, or textbooks, and can be described as teacher-centered instruction. This technique emphasizes direct instruction and learning through observations and auditory means. With this approach, teachers are viewed as authority figures and sources of information. Learners receiving instruction in this manner sit back, absorb the information presented to them, and never truly engage or interact with the content. In other words, they are passive learners. Students do not have a voice with this educational philosophy and are not consulted in the decision-making process. Traditional classrooms are arranged so that all students are the same age and all students within the classroom receive the same curriculum despite interest or ability level. Rote memorization and regurgitation of information is paramount with this system, and core content areas are presented as separate entities with little to no connection between topics. In order for students to be adequately prepared for 21st century challenges and able to compete in a global economy, a major overhaul is needed. It is essential for students to be thinkers and problem solvers, as well as able to carry out the processes of analysis and evaluation. Additionally, the key to effectively preparing students of the 21st century to either enter the workforce or attend college is through social cognitive constructivism. Social cognitive constructivism is a theory based off of the work of Lev Vygotsky that hinges on the notion that ideas are constructed through interactions with the teacher and other students. The foremost concept is that ideas are constructed from experience to have a personal meaning for the student. Vygotsky abandoned the hypothesis by cognitivists such as Piaget, which stated that the separation of learning from its social context was possible. Vygotsky argued that all cognitive functions originate in and must therefore be explained as products of social interactions, and that learning was not simply the assimilation and accommodation of new knowledge by learners. It was the process by which learners were integrated into a knowledge community. Social cognitive constructivism centers on the assumption that cognitive development is limited to a certain range at any given age. Full cognitive development requires social interaction, and the development of language and articulation of those ideas is central to learning and development. Vygotsky's theory also concentrated on the zone of proximal development, which can be defined as the distance between the actual developmental level as determined by independent problem solving and the level of potential development as determined through problem solving under adult guidance or in collaboration with more capable peers. With social cognitive constructivism, learning occurs as students reconstruct and appropriate for themselves elements of meaning and skill that have their origins in guiding activities that occur between the student and the more accomplished other. Social cognitive constructivism holds to the idea that both teacher and student must be active in the learning process, and that although students must be active in the construction of new knowledge, students do not construct knowledge in a vacuum. They require direction, guidance, and instruction that is sensitive to their existing levels of understanding relative to the skills and knowledge under construction. Three of the most common instructional practices in constructivist classrooms are that the teacher acts as a facilitator, lessons are student-centered, and students are actively involved. Education theorists have influenced current trends in education by providing a focus on the process of children's thinking, not just in products, recognition of the crucial role of children's self-initiated, active involvement in learning activities, a de-emphasis on practices aimed at making children adult-like in their thinking, and acceptance of individual differences in developmental progress. Furthermore, some classroom applications of Vygotsky's theories are that instruction can be planned to provide practice in the zone of proximal development for the individual children or for groups of children. Cooperative learning activities can be planned with groups of children at different levels who can help each other learn, and scaffolding. For example, a classic traditional lesson on imagery can be transformed into a student-centered constructivist learning experience with a few simple tweaks. With the direct instruction presentation of the lesson, the teacher would start off by offering students a description for imagery as well as examples. The teacher would then read aloud a book and have the students underline sentences in which imagery were used. A student-centered discovery of imagery would look quite different. The teacher would begin by theatrically reading aloud a book to students and instructing students to put a star by words that cause them to picture something. Students would then work with a partner to draw pictures for all the stars they have in common. Next, the students would partner up in groups of 4 and communicate what they have drawn. During this time, students would also be instructed to discuss how the story was made more interesting by being able to see pictures in their minds. At the conclusion of the lesson, the teacher would disclose that this is called imagery, and instead of supplying students with a definition, students would be asked to collaborate with their groups and create a definition. This example lesson provides opportunities for students to engage with the content and practice critical 21st century skills such as collaborating with peers, creating and explaining phenomena in terms of concepts. Another traditional lesson that could be transformed into a more engaging constructivist lesson would be a lesson on how magnets interact with each other. Instead of just lecturing students or showing a PowerPoint on magnets and their properties, constructivist teachers could allow students to explore magnets themselves, thus confirming students' prior knowledge of the magnets. Through experimentation with the magnets, students may even discover that magnets attract through a sheet of paper or thin notebook. Teachers could promote such inquiry by placing index cards on each student's desk and allowing them to discover if magnets will attract or repel each other through the index cards. Next, teachers could put 2 magnets together so they attract and make a stack of 2. The teacher could then ask students whether they think 2 magnets like this or a single magnet is stronger. Without answering the question, the teacher would provide a plethora of magnets to the students so that they could uncover the answer to this question on their own. Exploration of this lesson could continue, and students could even graph the results of their experiments in their science notebook or by using a computer. At the conclusion of this lesson, the teacher could pose questions for students to answer in their notebook, including: what evidence demonstrates that the attractive force of magnets can act across a distance? And explain the data from the graph that shows the relationship between the number of magnets in a stack and the distance through which they can attract another magnet. This lesson actively involves students and allows students to discover information on their own, as well as provides opportunities for students to integrate math, access technology, use critical thinking, cite evidence, and explain their thinking. According to Yeager, constructivism implies that learning is ongoing and continuous, and the constructivist approach to learning is formative rather than summative. Its purpose is to improve the quality of learning, not provide evidence for evaluating or grading students. Furthermore, 2 approaches to learning which reinforce constructivist philosophy are problem-based learning and project-based learning. Problem-based learning is a teaching method in which students gain knowledge and skills by working for an extended period of time to investigate and respond to an engaging and complex question, problem, or challenge. On the other hand, project-based learning is a dynamic approach to teaching in which students explore real-world problems and challenges. These two approaches to learning support constructivist beliefs because they both focus on an open-ended question or task, provide authentic applications of content and skills, build 21st century success skills, emphasize student independence and inquiry, and are longer and more multifaceted than traditional assignments. To summarize, the constructivist teacher is one who allows students to make discoveries, engage with the content, develop critical thinking and problem-solving skills, collaborate with peers, and apply content and skills acquired through authentic methods. In order for the educational system to produce graduates who are college and career ready and who possess essential 21st century skills, education must transform into a more constructivist approach.